Hello friends, welcome to Damu Education. If not yet subscribed, please subscribe and click the bell icon. So in this module, we are going to discuss a fourth question. What is that? PQR, they are given is a triangle right angle at P. So they are given condition that is right angle at P and M is a point on QR such that PM is perpendicular to QR. So then show that PM square will be equal to QR into MR. So this one we have to show. So what are the given conditions? Let's write it first. So given that, so triangle PQR, whatever it is, angle P will be equal to 90 degrees and PM is perpendicular to QR. PM is perpendicular to QR. Perpendicular means PM is making 90 degrees with the QR. So that is the condition. These are the things RTP required to prove here is. So what is required to prove? So PM square will be equal to QM into MR. So QR into MR, whatever it is, QM into MR. So QM into MR. So that is the case here. So we have to show that one. Then what is the proof? So let's write is proof here. So QM into MR. So proof here is, let's consider in triangle PQR and triangle PMR. So PQR and MPR. So how I am taking PQR MPR here is, let's take it P. In PQR, P at right angle, that is 90 degrees, and Q at the height point you taken and base point is R. So in MPR also we are taken M at that point 90 degrees. This is height point. So for these triangles, this is height 1 and base is R. R is the corresponding things. So like that we have to take it. So first of all, let's take it here. Angle P will be equal to angle M, that will be equal to 90 degrees. So here it is making 90 degrees, that is right angle in both the right angle. So here what you can write here is triangle PQR will be similar to triangle MPR. So similar to each other by using of AA similarity criterion. So both the triangles. So first of all, we are taken that two angles here M and P. In both the triangles, R is a common angle. So but two are similar to each other. So you can similar to each other. Then what you can write? So similarly, you can take these one triangles. So let's consider triangle PQR or PQR. Let's take it PQR only. So PQR. So P is at right angle 90 degrees, and so you can take 90 degrees here in this triangle. I want to take MQP. So we are started at 90 degrees, here also 90 degrees, triangle M and PQR, right, height. So here also Q is a common, and what is that next one? P. So R for that P. So it is a base. So in this triangle you can take it as, so here angle Q, that is PQR will be equal to, what is that? MQP, that is common angle in both the triangles, and angle P will be equal to angle M, that will be equal to 90 degrees. So it is also similar to each other. So PQR is similar to MQP. So here both are similar to each other by AA similarity criterion. So what I am trying to do here is this triangle separately we are taken, and after that we are showing that these two triangles are similar to PQR and both are similar to each other. So let's consider triangles. So ratio of corresponding sides of similar triangle are equal. So ratio of corresponding sides of similar triangles are equal. So that is a condition. Let's consider in these two triangles, what you can take it here as PM by PM. Height we are taken PM by MR. PM by MR. Here we are taken. So height to the base. MR. In this triangle, you can take as it is QM. Why? Because we are taken PM for that height. So this is the height. So here in this triangle H1, this is H2. And this is base B1 and this is base B2. So PM we are taken height to the base MR. In this triangle QM by PM. So you can cross multiply. What you can write here, PM into PM, that will be equal to QM into MR. So PM square will be equal to QM into MR. So we are hence proved. Thanks for watching. Please subscribe.